Of all the right triangle problems, this type tends to offer students the most challenge. So we're going to walk through this one together and also use the calculator to solve it. The most critical part really is to draw an accurate picture so that you can see the relationships that you're looking for. So let's read through it. From a point on the street, the angle of elevation of the top of the John Hancock building is 65.7 degrees. So let's draw that. Here's the John Hancock building right here. And somewhere on the street over here, we take an elevation and find that from the horizontal, the angle of elevation to the top of the building is 65.7 degrees. And then from a point on the street that's 100 feet closer to the building, so you're standing right here, you move 100 feet closer so that this distance is 100 feet. Then you take another angle of elevation to the top of the building, and that angle is 70.1 degrees. And we want to find the height of the building, so we'll call that H. So you see we have this obtuse triangle right here. You don't want to do anything in that obtuse triangle. We want to work with the right triangles here. And we have a large right triangle. This is your right angle for both of these triangles, this one here, and then this larger triangle that's out here. So the thing that those two triangles share, those two right triangles, is this height, and that's what we want to focus on. Now I don't know how long this leg of the right triangle is, so I'm going to call it X, and that goes from right here to right there. So if I'm talking about this big long side of the large right triangle, then that distance is going to be X plus 100. Alright, so first you can start in either triangle you want, but we'll start with this smaller one right here. I know this angle, I'm looking for the height, and I have labeled the adjacent side. So opposite adjacent means I want to use tangent. So the relationship is tangent of that angle, 70.1 degrees, is equal to H over X. And if I solve that for H, then I'm just going to multiply the X to the other side. So H is equal to X times tangent 70.1. Let's do the same thing in the large right triangle. Again, we have opposite and we have an expression for adjacent. So we're going to call it tangent 65.7 degrees is equal to the opposite, which is H, over the adjacent, which is X plus 100. Just like we multiplied both sides by X in the previous problem, we want to multiply both sides by X plus 100. Make sure that you keep that grouped, otherwise your order of operations will not be correct. So in both of those triangles, H is the same thing. We have this expression for H, and we have another expression for H. So we're going to set those two expressions equal to each other since H is the same in both of them. So we could say X tangent 70.1 degrees is equal to X plus 100 times tangent 65.7 degrees. You could solve that algebraically, but it's quite a bit of in-depth algebra. So let's try graphing it instead. We're going to go to y equals, first turn your calculator on, and then let's go ahead and check the mode. Make sure that you're in degree mode since your angles are in degrees. And then in y equals, we're going to put each side of our equation. So I'm going to have X times tangent 70.1. In y2, I'm going to put the other side, X plus 100 times tangent 65.7. Then I want to look for the intersection of those. Now if I get impatient and I graph it right here, then you see that I get a line right there, and that's all I get. And I know that I'm expecting two lines. I want to know where this side is equal to that side, which is going to be the intersection of the two lines. So clearly my view window is not correct. So let's back up a little bit and let's look at the window. We know that X is going to be this value right here, and that X plus 100 is this distance. So we probably want something that's bigger than 100. This is really a guess. We know we can't have negative numbers for X, so we're going to start our X minimum at 0, our X max, I'm just gonna guess at 300. You can change your scale if you want, it doesn't really matter. The Y is the height of your building right there. So John Hancock building is pretty tall, so we know it's not going to have a negative height, so we'll start that with a Y min of 0, and the Y max is maybe 500. We may have to adjust these values. And now let's take a look at the graph of it. What I'm hoping for is to see both lines and the intersection of them. So I'm seeing both lines here, but I'm not seeing the intersection. If the intersection is not close to the window, then the calculator won't be able to find it. So when you get a problem like this, you have to go back to your window and adjust. It looks like maybe my X values are going to be fine, but the Y values are not big enough. So let's go back to the window and adjust the Y max. So I'm going to put 1,000 in there. And again, these are just not specific numbers that you have to use, but they're just in the ballpark. So there's my first line. Here's another line. It looks like my X values are not big enough either. I'm going to go ahead and second trace here and see if the calculator will find the intersection, see if it's close enough. So when it says first curve, I'm going to press enter because it's on Y1. When it says second curve, I'm going to enter because it's on Y2. And then for a guess, I'm just going to press enter. Okay, if it tells me no sign change, then that just means that my window is not the right size. So let's go back to the window, and I'm going to change my X maximum to 500 and graph it one more time. This is the kind of trial and error that you just have to get used to when you are using your calculator to solve problems. Okay, so this time it's pretty close. Let's try again. Second trace, intersection, first curve, press enter, second curve, press enter, guess, press enter. And that time, even though I couldn't see the intersection, it was close enough that the calculator found it. Now I have an X value here of roughly 404. I have a Y value of 1,117 and a decimal. The Y represents the height. The X, remember, is the distance that you're standing away from the building the second time. So what we're looking for is the height. So we're going to use this Y value of 1,117 feet.